Okay, it's time to derive two equations that are probably the two most important equations definitely in kinematics. Some might even say in the basics of physics. Okay, these are two equations that by the end of the week after Thanksgiving, maybe even by the end of next week, you'll know them off by heart. You'll be able to say them backwards while standing on your head, humming O Canada and Swahili at the same time. Okay, so what I'm going to show you right now is how to derive them. Will I ever ask you to do this? No. I just want to show you that they don't just magically show up, that they come from what we already know. It's the result of us combining other equations together so that we can solve something more directly rather than going through a whole bunch of steps. Okay, so what we're looking for is an equation for distance traveled, or the displacement, and the final velocity or final speed during a constant acceleration. So first for distance traveled. So we're going to start with what we know. We know from grade 10 science and earlier in grade 11 physics that A is equal to VF minus VI over delta T. That equation you should recognize. Now we can rearrange this for VF, and to do that we would multiply both sides by delta T. So A delta T is equal to VF minus VI, and then add VI to both sides so that we would get VF equals VI plus A delta T. Okay, so we have this. Now we also know, another equation that we also know is V average. And we know the average of anything is equal to like the average grades 1 plus another divided by 2. So we can find an average velocity by adding the final to the initial and dividing by 2. So if we substitute for VF, this VF that we got up here, if we substitute that in here, we would have V average is equal to VI plus A delta T plus VI. So the VI A delta T is what we just subbed in, and the plus VI is there, and then this is all over 2. Okay? Now we can add the VI and the VI, so we would get 2VI plus A delta T all over 2. Now I could write this instead as 2VI over 2 plus 1/2 A delta T, right? I could put the 2, separate the fractions. The 2VI over 2 is just going to become VI. So we would have VF is equal to VI plus 1/2 A delta T. I need to do one more substitution. And what I'm going to do is we also know that VF is equal to delta D over delta T. So if we're talking about average velocity, this would be displacement. So delta D over delta T, if we sub it in for VF, is equal to VI plus A delta T. And now I want to get this delta T off the bottom. Remember, we want a distance traveled or displacement. Multiply everything by delta T, and you get delta D is equal to, the delta T goes, multiply this term by delta T, so VI delta T, multiply this term by delta T, 1/2 A delta T squared. This will give you the distance traveled. It also gives you the displacement as long as you put in your positives and negatives, like if you're initially going east and the acceleration is west. So it's distance traveled or displacement of an object in a given period of time when the object is accelerating. You should star this equation, you should highlight it, you should make fireworks coming out of it. This is probably the most important equation. Before long, you will be able to say delta D is equal to VI delta T plus 1/2 A delta T squared without even blinking. That's one. I promised 2. The second one was to find the final speed or the final velocity. So to do that, we're going to go back to our VF equals VI plus A delta T equation that we had arranged up here, this guy. And now we're going to rearrange it for time. Actually, I probably should have gone back to the original, A equals VF minus VI over delta T, and arrange it for time. So it becomes delta t is equal to VF minus VI over A. And now I'm going to take this, and hold on to your hats, I'm going to sub it into our brand spanking new equation here. So it's going to become delta D is equal to VI brackets VF minus VI over A from here, close the bracket, plus 1/2 A bracket VF minus VI over A, and unfortunately that T is squared. Remember I told you I would never make you do this. I just want to show you that it's coming from what we already know. So if I multiply through here with the VI, I will get VI VF, and then I will get minus VI squared, and those are both over A, plus 1/2 A, and when I square this, it'll be A squared on the bottom, and on the top it'll be VF minus VI times VF minus VI. All right, this A will cancel with the squared, so now I have an A under everything, so I might just bring it up here. So it'll be A delta D, and that will equal VF VI minus VI squared plus 1/2, and now I need to FOIL this. So VF times VF will be VF squared. VF times negative VI will be minus VF VI. Negative VI times VF will be minus VF VI again. And negative VI times negative VI will be positive VI squared. And now I can multiply through by my 1/2. Or maybe I could multiply everything by 2 to get rid of that 1/2 if that's better. Maybe I'll multiply by 1/2 just so I don't screw you up. So these two terms stay the same. In here I have VF VI and VF VI. So that's going to be 2 of them. So plus 1/2 VF squared, I'll add them together later, minus 1/2 VF VI, minus 1/2 VF VI, plus 1/2 VI squared. Okay, so look at this minus 1/2 VF VI, minus 1/2 VF VI, and a full VF VI or VI VF. These are going to cancel each other. Now I have a negative VI squared, and okay, so now I have A delta D is equal to negative VI squared minus, plus 1/2 VF squared plus 1/2 VI squared. Okay, if I multiply everything by 2, it'll be 2A delta D equals negative 2VI squared plus VF squared plus VI squared. I think that should be easier for you to see. Negative 2VI plus VI will be negative VI squared plus VF squared, and that's equal to 2A delta D. We said we wanted to solve for VF, so now we need to take the VI over. So moving up here, it becomes VF squared is equal to VI squared plus 2A delta D. This is the second equation. Star it, highlight it, make fireworks coming out of it, do the whole shebang. It is the second most important equation in kinematics. Okay, so these are the two ones. They will not be on this first test. The ones on this first test are A equals VF minus VI over delta T, and VAV equals delta D over delta T. These two new ones we're going to start to move as we move into the second half of the unit. So I wanted to show you where they come from, so the next day in class we can just begin to do some examples with them after we go over the stuff we need to go over to get ready for the test. Okay, so there they are. All right, now go work on your velocity versus time and displacement versus time graphs and your test review.